So this here is RStudio, okay? And so this week I'm assigning your first lab assignment, which is an assignment to basically download and install R and RStudio, and then try a few exercises and your first thing of doing a little bit of data stuff, okay? So what you're gonna do is you go to Google or whatever your favorite website, favorite search engine, and you type in R, okay? The first hit is going to be the R project for statistical computing, okay? And you go there, and the website looks like this. And you're gonna go under download, you're gonna click CRAN, okay? CRAN is like, well, whatever. So you click that, and then it says pick a mirror, so it's like all around the world. We have a server at UCLA. That'll probably give you pretty good speeds, but pretty much anyone in America will be pretty fast, and the other ones will be pretty good too. It's just you'll have to cross the world to download it, but you know, that's the magic of the internet. So anyway, so again, the idea is you type in R. First link is the R project. Then you go to CRAN, and then you pick a mirror. I default to picking UCLA's mirror, but you pick whatever you want. And then you click the appropriate one, Windows or Mac or Linux. I don't know.
We'll give a Mac, you use the Mac.
Yeah, of course. So use the appropriate one for your system, okay? So if it's Windows, you know, you click this thing for install R, and you download and you install the thing. Or if it's Mac, you download the package and you open that up, okay? So there's two things you got to install. So first you have to install R, okay? And this is known as vanilla R, and it puts basically a programming system on your thing, okay? It's free, okay? And there's no viruses or anything. It's nothing bad, okay? And then once you have R, I recommend searching for something called RStudio, okay? RStudio is a graphic user interface, a GUI that sits on top of R, okay? It's optional, and if you have an older computer, RStudio might crash on your computer because it requires a little bit more processing power. It's not going to slow. I mean, if you've got a modern computer, you're not going to notice any slowdowns or anything like that. But it requires a little bit more power. So if you have an older computer, you might be forced to use basic R by itself. But RStudio has some nice features that, you know, make handling things in R a little bit easier and nicer for users. So. And then so you click RStudio, and then you click download RStudio, okay? And then they're gonna say, you know, there's like just so you get the free one, the open source edition, download RStudio desktop, okay? Don't pay $1,000 for the commercial license, all right? So if you run a business, you're supposed to get the commercial license, but none of you are doing this for business right now, so just get the RStudio desktop, which is free. Save yourself $1,000, okay? Okay, so anyway, you download and you install that, and it'll show up on your computer, okay? And it'll look like this. I'm using a web interfaced version, but so here RStudio, and of course during the live demo in class it doesn't load properly, but anyway, oh well, it started loading. Okay, but anyway, when you start it up, it looks like this, okay? So vanilla R, if you get R all by itself and you can't get RStudio, is just this window over here. RStudio adds these extra windows to the sides, okay? And so this is what it looks like, and you can use it as like a calculator, and you can do like, what's 2 plus 6, and you hit enter, and it says the answer to that is 8. Okay, and then everybody asks, well, what is this bracket 1 bracket thing? Okay, well, R is designed for statistics, and so it's used to handling a whole bunch of numbers at once. Okay, and so it can handle things. It handles everything as vectors. Okay, vectors being like a long list of numbers. Okay, so you got like 1,000 numbers all at once. It's gonna spit them all out. Okay. So anyway, you can do things, division and powers with the caret function, or square roots of that. Okay, and so you're getting these nice numbers and things like that, and spits them
So
up.
you got like a number to the 52nd power, you just put that in there?
Yeah, that might create an overflow error, but let's see. Something raised to the 52nd power. Oh, look, it can do it. Okay. So if you're not familiar, this notation means 2.08241 times 10 to the 31st power. Okay. So yes, it can do quite a bit. There is a limit to its power, but it's pretty good. So they have built-in distribution calculators, which is what I want you to use for the first section of the quiz. Okay, and so we'll start with Pnorm. Pnorm is like having a built-in z-table. Okay, so basically into Pnorm you're going to enter a z-score. Okay, and it will tell you the area to the left of that z-score. So it's just like looking up the number. So right now I have Pnorm 0, and this would be the equivalent of looking up 0, z equal to 0 in your table. So what number should this spit back? 0.5, right? So I say Pnorm 0 and it spits back 0.5, okay? And so if I do Pnorm -1, what will this spit back? So this is how much is to the left of z equal to -1. So you're expecting something around 16%, right? Because we got 68% between -1 and +1. So I go Pnorm this, and indeed it spits back 0.1586553. If you look up -1, it gives you 0.1587. So the built-in table here has a few extra decimals of precision. Okay.
Does that mean that you can actually put more precision into the z-score?
Absolutely, absolutely. So one of the examples was, what is what percentage of beagles weigh less than or whatever it was, and I said, and our z-score was 0.33333 or something like that. Okay, so you could do Pnorm 0.3333333, and indeed this, well, I don't know, this is different than that. Okay, so if just adding an extra whatever.
You said you preferred four
Well,
digits?
yeah, I mean, I don't know. We don't need to get philosophical about it, but what's the difference between 1/10,000th? 4 decimals is you're up to the 10,000th position, and I don't know how much of a difference it makes. And so anyway, so yes, you can do this, and or you can even enter in fractions 1/3, and it gives you that, and so you get very good precise numbers here. Okay, and with Pnorm, you don't even actually have to turn them into z-scores. Okay, so I could say someone has a height of 65. The mean is equal to 64, and the standard deviation is equal to 3. Okay, so this is equivalent to having a z-score of 1/3. Okay, and I can hit equal, and indeed that gives me the same answer as entering Pnorm 1/3. and lastly, R actually expects things in a certain order, okay? And so I can just shorthand it and say Pnorm 65, 64, 3, and it understands that I'm talking about mean 64 and standard deviation 3. You can't just, the order matters, and if you want to know the order, you can always ask R for help, and you type in the question mark sign for what's the help me on Pnorm. I've got questions about Pnorm, basically is what it's saying. And you enter that, and it pulls up the help file. It shows up down here. If you use vanilla R, it opens your web browser. Okay, and you can see there's 4 things listed here: Dnorm, Pnorm, Qnorm, and Rnorm. And so Pnorm says, okay, you're going to enter in the Q, and the next number I'm expecting is the mean, and the next number is the standard deviation. And it also says 0 and 1, meaning if you don't enter those, I'm going to assume you mean 0 and 1 for the mean and standard deviation, which is essentially what a z-score is, right? Z-score has a mean of 0 and a standard deviation of 1. Okay. And it assumes lower tail, which means area to the left. You could say, if you wanted the area to the right, there's a couple ways. So if I want to know what, I could say lower tail is false, okay, and this would give me the area to the right. Or one other way is I could do 1 minus the area to the left, and it gives me that, right? So the Pnorm expression expects that you want the area to the left, but if you say I don't want the area to the left and you say false, it will give you the area to the right. Okay, false you always have to enter in all caps because it's I don't know, protected word in R, and it understands it as a true false value. You can't, you've got to say it all caps. Okay, or you can just do 1 minus Pnorm of that, and that will give you the area to the right as well. So those are equivalent expressions there. Okay. I usually just use the 1 minus version because that's 2 extra characters, whereas false is, I don't know, 6 because of the comma. So that's how I do it. Okay. So if I wanted to know what percentage of women are between 65 inches tall and 67 inches tall, how would I do this in R? I would do Pnorm. So I'm going to just, to write a comment, this just tells R, you put the pound sign or the hashtag, and you say, or hash character, basically, then R will just ignore whatever you write after this. So basically, you know, what percent of women are between 65 and 67 inches, inches tall? Okay, so it just ignores everything I wrote there. The way I'm going to solve this, I'm going to do Pnorm 67 with a mean of 64 and standard deviation of 3 minus Pnorm 65, mean of 64, standard deviation of 3, right? So the first one gives me the area to the left of 67. The second one will give me the area to the left of 65. And if I take the difference between those, I get the area in between. Does that make sense to you guys?
So the answer is to the right, always up there.
No. This is a so there's 2 terms here, right? This is the area to the left of 67. This is the area. The second term is the area to the left of 65, and I'm taking the difference between those, and that's the area in between 65 and 67. Okay, so that's Pnorm. Qnorm is the reverse reading of the table. Okay, so Qnorm says if you want the 50th percentile, or if you want an area of 0.5 to the left, the z-score you want to use is, what's it going to tell me? 0, okay? And if you want the area to the left to be 0.1, the z-score you're going to look up is going to be, I think you guys looked this one up earlier, negative 1.28, but it gives you a little bit more precision there. Okay? And so you can double check the table. Is, you know, if you look up negative 0.1 or 0.1003, you see, oh, that's even closer to, you know, negative 0.28. Okay, so anyway, you have that. So that's Pnorm and Qnorm, and again, same type of things. You can say, you know, what's the height of a woman in the 10th percentile, and you can give it a mean and a standard deviation, and it says, oh, woman in the 10th percentile is 60.15 inches tall. Okay. For binomial, you have D binom and P binom. Okay, so D binom is you say, well, what's the probability of getting 5 heads if I flip the coin 10 times and the probability of getting a success is 0.5? Okay, and it says the answer is that. So you know, so what is probability of getting 5 heads, or let's say 8 heads if I flip 10 times and prob is 0.6. Then I do D binom, what? 8, 10, 0.6. Okay, and again, if you're unsure of the order or how it works, you just say, I've got questions about D binom, and it lists them off, size and probability that way. P binom will give you from 0 through that number, okay? So if I do P binom 8, 10, 0.6, whoops, oh, I spelled it wrong, okay. P binom, it gives me 0.9536426, okay? And so what this is actually doing is it's actually doing D binom for the numbers, and I'm going to do C for concatenate 0, 1, 2, 3, 4, 5, 6, 7, and 8. It's saying take all of those numbers, and I get all of these numbers. And if I add all of these numbers together, I'm going to get 0.953642, whatever, okay? And I can actually do that. I can say, give me the sum of everything here. So this line, D binom 0, 1, 2, 3, 4, 5, 6, 7, 8, 10.6, basically represents all of these numbers here. There's 9 of them. And if I say sum, says take all of 9 of those numbers and add them up together. And we see we get the exact same thing here. Okay. So this P binom, whenever you stick an 8 in here, it's doing 0 through that number.
Is that similar to the question we had earlier, the 70 through 90?
Yeah, so this is how we would answer that question. Okay, so I don't remember how that question was, but I think it was like I flip a coin 100 times, and you know, probability of heads is 0.8. You know, what is probability of getting between 70 and 90 heads? Okay. So how would I answer this using P binom? Okay. So I would do P binom 90, 100.8. So this gives me the probability of getting 0 through 90. Okay, but then I want to subtract off everything else that's not between 70 and 90. So I would subtract off P binom, what?
70?
Not 70, but 69, because I want to include 70. Okay, because if I do 70, it would subtract off the number for 70. Okay, so I do P binom 69, 100.8, and it says my answer is 0.9916. And I think the number that we looked up was something in that vicinity also, right? Like 0.9914 or something. Okay, so our answer is a very good approximation for this is the exact value that that the binomial distribution spits out. Okay, and it's not hard to do it with the computer. You know, we could do it the other way, d binom, and I could do 70 colon 90. This is a shorthand way of writing 70 through 90, every single number there. 100.8, and then, you know, it calculates all 21 numbers for me very quickly. And then we could say we'll add all of those together, and we get our answer that way also. Okay. Yes. There's no continuity correction here, because we're the binomial and we're answering it with the binomial. Okay, we only use the continuity correction if we've got a binomial and we're trying to approximate it with the normal, and we really only bother doing that when we're doing it by hand. Okay, we wouldn't do it if we've got a computer. Okay, because the computer can give us the exact numbers. We don't need to do any kind of continuity corrections. And I don't know if it will error out if I try to stick in a 0.5. Yeah, it says, hey, wait a second. This is binomial distribution and you're giving me 90.5. I don't know what you're talking about. Okay? So yeah, when you're doing the binomial, no thing. Okay. Oh gosh.
Warning messages are when you.
Yeah, warning messages are when you make a mistake.
Right.
Okay, so that was the first half, and then the second half, I want you guys to load a data set, and I'm sorry that I'm running over my time here. So I've got a data set. You can copy this this link here, and it comes from the World Health Organization, and it should download. I think my connection to the internet's a little off here. It should download a CSV file, okay? And I've got a little program or a video that shows you how to import a data set from the text file, or you can just read it in. But let's see, you know, from text file, and I actually have it loaded here. And then you say, oh, it's, you know, comma separated. And rename your text data set to something. And because this is on blood pressure, I'm just going to call it BP. Okay, and it imports this data here. Okay, and you can see the data imported here. And so I called this BP, and so I can reference columns in blood pressure by, you know, I can say BP $country, and if I hit enter, it's going to give me the list of everything here, and I've got 582 rows listed, you know, starting with the Republic of Korea, Canada, Peru, etc., etc., etc. Okay, and the column that I'm interested in is this column numeric, which is the numeric, I think, systolic blood pressure, average systolic blood pressure for each of these countries. And I'm going to ask you to make some histograms, okay? And so the instructions I've put here are intentionally a little vague, okay? Because I want you to explore using R and kind of discovering certain things. Now, if it's frustrating or you get stuck and you hate it, send me an email. That's fine, okay? But basically, what you're going to be doing is you're going to go to Google or whatever search engine you like, and you say, how do I make a histogram in R? Okay, or something like that. You know, histogram R, and of course my internet connection is broken, or no, it works fine, but. And you're just going to kind of click these links and try to learn R by example here, okay? When you first get started, you're going to probably run into errors when you try to do the mean, okay? Because you've got some missing data here. And, you know, if I say, you know, what's the mean age? There's 4 kids in my family. and three of them, the ages of three of them are, 10 years old, 11 years old, and 12 years old. But what's the average of all four kids' ages? Your answer is I can't tell you because I don't know the fourth kid's age, right? Because that fourth kid could be 20, that fourth kid could be 2, it could be something else. So when you ask R, give me the mean of these numbers, and some of those numbers are missing, it's going to say, I don't know what to tell you. So you have to tell R, okay, just pretend like those missing numbers don't even exist. Give me the average of the numbers you do have. Okay, and there's a option in the mean function to do that. But try it out and do your best. And if you get stuck, don't hesitate to email me. Okay, this is supposed to be a learning exercise, not a frustration exercise. Okay, but I think with some effort you can get pretty far. Okay, so good luck with that. We'll see you guys next